So we start here with our notes for today. So again, covalent bonds are going to be where they share electrons, co and valent. They are sharing electrons. That's something we should already know. And once again, that is going to be between a nonmetal and a nonmetal. So elements are going to form bonds in order to decrease their potential energy and become more stable. This is going to help them not be as reactive. This is done by transferring electrons. We can have ionic salts, or sharing to form molecules, which is going to be covalent molecules. A covalent bond is the force of attraction that holds together two atoms that share a pair of valence electrons. Remember that your valence electrons are going to be the electrons that are found on the outer shell. They're going to be on the very outside. The shared electrons are attached to the nuclei of both atoms. This forms a molecule consisting of two or more atoms. Covalent bonds can only form between atoms of nonmetals. So once again, we see that again. It's a nonmetal with a nonmetal. If we think about our periodic table, our nonmetals are going to be over to the right side. They are going to be these over here. Again, periodic table, you've got your metals taking up most of it on the left side, your metalloids here in the middle where we have that stair-step pattern, and then your nonmetals are all over in this area. So any bond that is between two nonmetals, that is going to be a covalent bond. The two atoms that are held together by a covalent bond may be atoms of the same element or different elements. So for example, we could have two atoms of oxygen making O2, or we could have something bonding with chlorine, something bonding with phosphorus, something bonding with carbon. Remember that hydrogen over here is a nonmetal, so we'll often see like hydrogen bonding with chlorine. As long as it's two nonmetals, that makes a covalent bond. When atoms of different elements form covalent bonds, which will create a new substance, this is called a covalent compound, and this is a result. Water is a great example of a covalent compound because remember that water is H2O. We have two hydrogens with one oxygen, and they come together. Both hydrogen and oxygen are going to be nonmetals. So as long as they come together to form their compound, it's going to be a covalent bond. Covalent compounds are often called molecular compounds. They form between two or more nonmetals. They can form also between metalloids and nonmetals. Because the electronegativities are similar, they are going to share electrons to complete the valence shell. We want a total of 8 electrons. So remember, if we did this before break, but if we look at hydrogen and oxygen combining to form water, we'll have hydrogen over here with one. We'll have oxygen in the middle and another hydrogen. Hydrogens each have one. Our oxygen is going to be a part of the 6th group, so it'll have 6 valence electrons. So 1, 2, 3, 4, 5, 6. And remember, we show covalent bonds by drawing the line between the two. And then when you count out how many electrons are shared within that covalent bond, you're going to get to 8. Remember that hydrogen is only going to want 2 valence electrons. So here, even though hydrogen does not have a full 8 electrons, it's on our first shell. So the first shell can only hold 2 electrons, so it's only going to want 2 at most. In order to name our molecular compounds, we are going to look at the binary or molecular system of naming. This is used when you have 2 nonmetals that are bonded together. For many nonmetal compounds, they can combine in different ratios, much like we see with hydrogen and oxygen, we have 2 H's with 1 O, but you could also have H2O2, which would then create hydrogen peroxide. So depending on the different ratios you have, that's how you're going to figure out their names. Your naming system is going to then describe the number of each atom that is present in the compound. For this system, you will choose a prefix to describe the number, and then a suffix of the second element will then change to "ide." We have already seen the suffix changing to "ide" before, so hopefully you guys are comfortable with that. Some of these numbers you guys might know from before. One is mono, or it could also be seen as mon, depending on what comes after it. So sometimes that O is left off if the following word starts with a vowel. You also have di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Again, some of these you might have heard before, like a decade is 10 years, octagon has 8 sides, not too bad. Hexagon, like a stop sign, has 6 sides, so it's not too bad. So if we're going to look at some examples, we can start looking at the number that are there. Our first example is CO2. Now, for your very first element, you are not going to want to start with the number. If your first element only has 1, you're going to leave mon off or mono off. But I think that's our only kind of special thing that goes there. So we can look at CO2. So all we have to do is find the names for them. So you can go back to your periodic table if you're not comfortable with your names of the atoms yet. So C, if we look on the periodic table, is right here. C is carbon. And then we have O, which is oxygen, and we have 2O. So if your first one is just with a single atom of that type of element, we're going to leave off mon. So that would make it carbon. And then we look for how many atoms we have of our next one. We have 2 oxygen, so we're going to go to 2, which would be di. And then oxygen, remember that we are changing our second one to end with "ide," so it would become dioxide. And look at that, we have that answer right there with B. So I want you guys to go ahead and pause and try to see if you can figure out what names go with each of these. So go ahead and pause. You guys have those filled in, let's talk about them. So we have an N with an H3. Remember that when you have the first one starting with only 1 atom of that element, you're going to leave off mono. So N, if you look at your periodic table, N is a nitrogen. So it's going to be nitrogen. And then we look at how many we have is 3. So it's going to be tri. And then whatever element that is with the ending, change to IDE. So remember, hydrogen would then change to hydride. If there's 3 of them, it's trihydride. So the second one should be nitrogen, trihydride. This one here, oxygen with 2 fluorine, is going to be oxygen difluoride. Here we have 2 hydrogens. Because the first one now has 2, we are going to include the prefix for our first element. So we will have dihydride, and then we are going to look at how many we have here. It's an S. So we know that it is sulfur, and we only have 1 of them, so it's going to be monosulfide, because we're changing the N to end with IDE, so that will be C. And then our last one is going to be 2 hydrogens, so dihydrogen, and then O is monoxide, because we are adding the mon part. Now again, if you look, sometimes you guys like to add the whole mono and then oxide. But when you do that, you put 2 vowels next to each other. So that's when you leave off that second O, or the first one. So, hey, hopefully you guys got that. So we can continue on. Something that hopefully you guys noticed, one isn't necessary to include a prefix for the first element. We included a prefix anytime our first element had more than 1 atom. When the element has more than one atom. When is it necessary to include a prefix for the second element? Every single time. The prefix mono is used only on second elements. Remember, we didn't use monocarbon, we didn't do that. We didn't do mononitrogen. We left that first one. If it only has one element, we leave the name as is. The second element name is then shortened, and we add an IDE ending. Go ahead and flip on over. So again, I have given you guys this part here to make sure that you guys don't have to flip back and forth a million times. Again, we are only going to use mono for the second element. If there is only one in the first element, then you do not use a prefix. So take a look at that star right there. And then for hepta, the O in mono and the A in hepta get dropped when combined with oxygen. So just make sure that you keep that in mind. Again, if you have like a double vowel and it just sounds kind of weird, you're probably dropping the O on mono. The least electronegative atom goes first in the formula. So remember that electronegativity increases as we go to the top right. Fluorine has the highest amount of electronegativity in it. If you guys still have your little paper, I did give you your own chart of that has all of the numbers on there. I had you guys, hopefully, type them into your periodic tables. So if you have that, awesome. If not, well, you better do some memorizing. But those are there. So the ones that are going to be to the top right are going to come first when you are putting your covalent bonds together and naming them. So let's try a couple of these together and see how it goes. When you are writing the formulas for covalent bonds, we did the crisscross of the charges because they are sharing valent electrons. Charges do not matter. So because they are sharing valent electrons, charges do not matter for covalent bonds. You are simply just going to write the name how the name says, and you do not reduce to the lowest forms. So for example, we have these names. We have dinitrogen monoxide. Di is 2. Nitrogen, if you need to check back on your periodic table, find nitrogen. Nitrogen is shown by the letter N. So it's going to be N, and then a subscript of 2, so we write it small and underneath. Mon is going to be 1. Oxygen is just O. Remember that if you only have one, you do not have to include the number in the subscript portion. Dichlorine heptoxide. Di is 2. Chlorine is Cl. Hept is right up here, 7. Oxygen is O. So Cl2O7. We've got carbon. It has no prefix on it, so that means that it is just 1. Carbon is shown by the letter C. Di is 2. Sulfide is S for sulfur. So we have C with a 1. Remember, we don't write it when there's a 1. CS2. From here on out, you guys now have some practice to work on. We're going to flip over. Have a quick little 25 questions here. You are just going to write the names of the formulas and then write the formulas for the names. Again, it's as easy as this one just says sulfur dioxide. There is no beginning, so it's 1 sulfur. Di is 2. Oxide is oxygen, so SO2. Work on this when I get back. We will come together, but I want to see this done by the time that I am back from my meeting today.